Hello, math students. It's Mrs. Marcellus, and with me again today is my furry friend, Barkamedes. In this lesson, we're going to find the volume of triangular prisms. Today's learning objective is, students will find the volume of a triangular prism by applying knowledge of the volume of a rectangular prism and utilizing a formula. Before we begin, we need to review some vocabulary. Volume is the number of cubic units needed to fill a three-dimensional figure. A triangular prism is a three-dimensional figure with two parallel bases that are congruent or equal triangles. The height connects the two triangular bases. And something that's going to be very handy for us is every triangular prism is 1/2 of a rectangular prism. I bet that will be really useful when we try to figure out the formula for calculating the volume of a triangular prism. Let's see if we can figure that out. As we saw when working with rectangular prisms, the volume was the area of the base that the prism sat on times the number of layers, or its height. This is true for any right prism, regardless of the shape of its base. A generic formula to find the volume of a right prism is the area of the base, or capital B, times its height. One way to approach finding the volume of a triangular prism is to apply this generic formula of V equals capital B times H. The capital B represents the area of the triangle base that the prism sits on. We then multiply it by the number of layers there are, or the height of the prism. We can also use the fact that every triangular prism is half of a rectangular prism and approach finding the volume a different way. We can start by using the volume formula for a rectangular prism, which is length times width times height, and since the triangular prism is always half of that, we divide by 2. No matter how you approach finding the volume, you must remember to apply a label of units cubed, because we are filling up the interior of a three-dimensional object. Let's find the volume of this Toblerone box. One way to approach this is to use the generic formula, V equals capital B, or area of the base, times the height. Capital B will be the area of the triangle at the end. The area of the triangle can be found by multiplying its base times the height, or 4 times 10, then dividing by 2. The area of the triangular base is 20 centimeters squared. Next, we multiply that times the height of the figure. This is 19 centimeters. 20 times 19 gives us a volume of 380 centimeters cubed. A second way to calculate the volume is to apply the fact that every triangular prism is half of a rectangular prism. We would first multiply the length times the width times the height, and then divide by 2. This would be 10 times 4 times 19, which equals 760. When we divide by 2, we again get a volume of 380 centimeters cubed. Next, let's find the volume of this tent. One way to calculate the volume is to use the generic formula of V equals capital B, or area of the base, times H, or height. Capital B will be the area of the triangle base, and we would calculate that by multiplying the base and height of the triangle and dividing by 2. The base of the triangle is 6.5 and its height is 8. 6.5 times 8 is 52, and that divided by 2 gives us an area of 26 feet squared. Next, we must multiply this area of the base times the height of the figure. There are 2 dimensions to choose from, so we have to figure out which one is the height. The height always connects the two bases. In this example, that would be the front and back of the tent. The length of 10.2 feet connects the front opening to the back opening. 9.7 is just one of the slanted sides of the triangle, so we won't use that number in our calculation at all. To finish calculating the volume, we will have to multiply 26 feet squared times 10.2 feet. The volume of the tent is 265 2/10 feet cubed. We can also calculate the volume by applying our knowledge that this triangular prism is half of a rectangular prism. We will first multiply the length times the width times the height, then we will divide that by 2. The length and width are the dimensions that we use to calculate the area of the triangle, and the height is the height of the prism. Therefore, we'll multiply 6.5 times 8 times 10.2 and divide by 2. This also gives us the volume of 265 2/10 feet cubed. In this problem, we're given the volume and asked to find the missing height of the figure. We can do this using our formula, volume equals big B times h. We know the volume, and to calculate the area of the triangular base, we will multiply its base times height and divide by 2. 12 times 16 divided by 2 equals 96 meters squared. Now we can plug these values into our formula. 1920 equals 96 times the height, which is represented by the variable x. To find the missing height, we will then divide both sides of the equation by 96. When we complete this calculation, we find that the missing height is 20 meters. We can also solve by using our knowledge that every triangular prism is half of a rectangular prism. We would use the formula volume equals length times width times height divided by 2. We can now plug in the known values. The volume is 1920, and this will equal a length of 12 times a width of 16 times the height, which is represented by the variable x, divided by 2. There are multiple ways you can solve from here. I'm going to start by multiplying both sides by 2. This gives us 3,840 equals 12 times 16 times x. Next, we can replace 12 times 16 with 192. To solve for x, we will then divide both sides of the equation by 192. This gives us a result that 20 meters equals x, which is the height of the triangular prism. Let's find the missing dimension of this tasty-looking piece of cheesecake. Since we are missing a dimension of the triangular base, it really doesn't matter which formula we use or approach we take. Either way, we will end up solving essentially the same equation. Let's plug the known values into both and go from there. If we use V equals capital B times H, we will solve 22.5 equals 6 times x divided by 2 times 3. That would be the area of the triangular base times the prism height of 3. If we use volume equals length times width times height divided by 2, we will end up with 22.5 equals 6 times x times 3 divided by 2. There are many ways we can solve from here. One thing we could do is use the commutative property to rearrange the values and multiply 6 times 3. This will leave us 22.5 equals 18x over 2. From here, we could either multiply both sides times 2, or we could simplify the fraction. I think I'll do that. 18 divided by 2 is 9, so that leaves us with 22.5 equals 9x. Next, we will divide both sides of the equation by 9, and that will give us our final answer of 2.5 equals x. The missing dimension of this piece of cheesecake is 2.5 inches. Well, Barkamedes, there sure are some sweet triangular prisms out there. Toblerone, cheesecake. What else can we think of? How about a nice slice of watermelon or some pan pizza? I don't know about you, but this sure is making me hungry. What do you say we go get a nice, tasty triangular prism treat? Since it's snack time, we're going to say goodbye for now, math students.